Hi, how you doing, advanced math fans? We're going to look at some more statistics today. And so what I want to look at today is we're going to look at some things that have to do with z-scores. And so a z-score has to do with normal distribution still. So we talked about that bell-shaped curve, that normal distribution curve. What we're going to do today is see if we can figure out how to standardize that and find out what percent of scores are below or above a certain score based on what the mean and the standard deviation is for that distribution. So what is a z-score? Well, it's a way to standardize this. So it's sometimes called the standard normal curve, where instead of using the mean and the standard deviation and putting the mean right in the middle and going standard deviations, we just say the mean is in the middle and we go this many z-scores. So one standard deviation to the positive direction would be a +1 for a z-score. Two standard deviations to the positive direction would be a +2. If you go the negative direction, if you go smaller than the mean, a one standard deviation below the mean would be a -1 z-score. Two standard deviations below the mean would be a -2 z-score. And so it's really just a measure of how many standard deviations an entry is away from the mean. Now, if it's above the mean, it's going to be a positive z-score. If it's below the mean, it's going to be a negative z-score. So that's all a z-score is. How many standard deviations are we away from the mean? Now, there is a formula for this, but this formula makes perfect sense if you think about the definition of this. Because what we do is we take an entry, we subtract the mean, so that tells us how many units we are away from there, but we want to know how many standard deviations we are away from there. And so if we know how many units we are away from there, divide that by the standard deviation, that tells us how many standard deviations we are away from there. And we have to make sure the order is in the correct order with the subtraction, basically because if we do the entry minus the mean, anything above the mean will come out positive, anything below the mean will come out negative, which is what we were saying here with the positive and negative. So to figure out what these are as exact percentages, you can find tables all over the place. I'm going to supply one for you guys on Google Classroom, so you can use that one. You could also Google this. You can find them all over. If you just Google z-table images, you're going to find like a million of these that pop up. So we're going to look at an example of this. So I did ACT scores. So I did a little research on ACT scores, and it actually changes slightly every year. But for the year that I looked up, the mean ACT score was 21, and the standard deviation ACT score was 5.4. Now, if you don't know a lot about ACT scores, it's basically on a scale up to 36 would be a perfect ACT score, which very few people ever get. And so this scale 21 is the average, 5.4 is the standard deviation. So we're going to look at a certain score using those stats and see if we can find out what the z-score is for a score of 26. Now, right away, we should look at the mean, look at the score 26, and know our answer should be a positive z-score because it's above the mean. And so to find this, we basically want to know how many numbers are we away from the mean. So if we go more formula style, we do 26 minus 21 divided by the standard deviation, which is 5.4. So in other words, we're 5 units away from the mean, which means, just think about it logically, we're a little less than 1 standard deviation. So our z-score is going to be a little below 1. And so we're going 5 of the 5.4. And so 5 divided by 5.4 would be how we compute our z-score. And if you do 5 divided by 5.4 and round it to the nearest hundredth, because the z-table we're going to be using only goes to hundredths. If you wanted to be really specific, you could actually find ones that go farther, but we're going to go to the nearest hundredth. That's as exact as we need to be for anything we're going to be doing. And so the z-score would be 0.93. All right, so the next part of this, which has to do with this number we just found, what percent of students score under a 26 then? We're going to use this z-score and go to our table and see if we can interpret how to read that table to figure out this percentage. All right, so we got a z-score of 0.93. What we're going to do with that is we're going to look on our z-table that I have for you guys, and I have it kind of zoomed in on one half of it because we're on the positive end of things right now. And so do you notice we have 0.9 if I look at this row right here? Now we want 0.93. Now these numbers up here are telling you the hundredths place that we need to go to. So this would be 0.90, 0.91, 0.92, 0.93 is right there. So since 0.93 is right there, that means, I know it says 0.8238, but to change that probability to a percentage, just move the decimal point 2 places. So in other words, we've got 82.38%. Now what this 82.38% means, this means that percent of students score under that. Another name for that is the percentile ranking. And so if you scored a 26 on the ACT, that puts you in the 82nd percentile, you could say. Because you're at the score where 82% of students are scoring equal or less than you. And that's what percentile rank means. And you've probably seen this reported if you've taken the ACT already and got those results. They give you a percentile ranking, and they also give you a composite one and one for each section for like the math and the reading and the science and so on. So percentile rank is just the percent of entries scoring equal to or less than that score. So let's try another one here. What is the percentile rank of a 32? All right, well, if we're going to figure this out, the first thing we need to find is what is the z-score of a 32? So a 32 is higher than the 21, so it's going to be a positive z-score. So to find out that z-score, we're going to want to do something like 32 minus the 21, and then divide that by our standard deviation of 5.4. So if I do 32 minus 21, we are actually 11 points above the average. The standard deviation is 5.4, and so do 11 divided by 5.4, we're a little more than 2. We're 2.04 is our z-score if we have a 32 on the ACT. So that's not the answer though, because that's our z-score. What we want is percentile rank. In other words, we want to know what percent of people are less than a 32, or what percent of people come out with a z-score less than 2.04. So we're going to go back to our z-table and see if we can figure this out then. So looking on my z-table, we're supposed to have 2.04. So 2.0 puts us in this line right here. And so we've got 2.00, 2.01, 2.02, 2.03, 2.04. So in other words, 97.93% is what that percentage would be. So in other words, that's the 98th percentile we're at if you score a 32. So now we want to know what percent of students score over a 17. All right, this one's a little different because 17 is lower than 21. This is going to have a negative z-score then. And so we're going to do something like this. We're going to do 17 minus 21 over 5.4 to figure out what our z-score is. So 17 minus 21 gives us a negative 4 in the top over 5.4, which gives us a z-score of about negative 0.74. All right, so we got negative 0.74 for our z-score. Let's go to the table and see what this tells us exactly on there. So we're on the negative side of the z-table now. And so on the negative side of the z-table, we need to come up with negative 0.74. So the negative 0.7 line is right there. And so there's negative 0.70, 1, 2, 3, 4. So negative 0.74 is 22.96%. So we've got 22.96% should be below that score. Now this is 22.96 below the score, but do you notice the question said what percent of students score over 17? The z-table always gives you the percentage or the probability of being below that number. But it's really easy to go the other direction because we know everything has to add up to 100%. And so if this is the percent below, to find the percent above, we really just want to do 100 minus this number. And so if I do 100 minus this number, I get that there's 74.04 or 77.04% above a 17. So about 77% of people who take the ACT get above a 17 on that. All right, now I want to try one more where we go the opposite direction. So this one, the question is, what score is the 80th percentile? And so we don't want to know what the percentile rank of a score is. We want to know what score we need to get a certain percentile. And so we're going to go to the table. We know the percentile we need to get is 80th. So we're going to basically look for 80% on the table. And from there, we're going to see if we can figure out what the score is. So looking at our table, we're trying to find the closest thing to 80%. Now there's probably not going to be one that's exactly 80%, but if we start to trace along here, we're going to see like we're getting closer, 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 closer. There we went over. The closest one is right there, 0.7995. And if we look at where that is, we're coming from over here, and so we've got 0.8, and then looking up to there, we got 4, so 0.84 would be the z-score that we want to use. So if we use 0.84 as the z-score, then what does that mean that we should do from there? So we know the z-score is 0.84. Well, basically here's what that means. We need to go up 0.84 of a standard deviation from the mean in order to get this number where 80% of the data is below it. And so remember what this number is. It's how many standard deviations we want to go above or below the mean. Now it's positive, that means we want to go above. And so basically I want to do 21 plus 0.84 of, and remember of means multiply, and so I want to do 0.84 of the standard deviation, which is 5.4. And so if I do that, that puts me at 25 point, it's like 25.536. I'm just going to round it to about 25 and a half. So 25 and a half on the ACT would get you to that 80th percentile. So that would be the score you need to score above 80% of the people who take it. And this is a ranking that some schools look at. They only accept students who are in the top 20% or in the top 25%. It depends on how rigorous the admissions are at that school. But that gives you an idea of how to compute this stuff and what that means, because I know you guys have seen percentile rank on some things before. And a common misconception with percentile rank is to see 50th percentile and think, oh, that means I'm a failure. 50th percentile is exactly average. That means you fell right in the middle. So that doesn't mean you're a failure, that just means you're right in the middle. And so make sure you keep in mind what percentile rank is when you're looking at those scores. So that'll give you an idea of how to use those z-scores. Make sure you're looking at that z-table. It's really important. I'm going to attach it on Google Classroom to this assignment so you can pull that up and use it. You can print it off if you want a paper copy. That's up to you. But this will get you a good start on how to use those z-tables and how to compute z-scores and find different percentiles and find percentages of data in certain intervals given a normal distribution.